Okay, so now we're going to continue with the notes from March 9th and 10th, and we're going to do some practice problems here. So for each one of these, I want you to, before you do the problem, explain and predict whether it would be endothermic or exothermic, because the problem tells you in its wording which one it's going to be. So temperature of 15 grams of water is increased by 30 degrees Celsius. Increased, that's our big thing there. So if you're increasing the temperature, which means you're increasing the average kinetic energy of the molecules, that means you need to add heat, right? Heat is going to go into it. Endothermic. Okay, temperature is increasing, which means heat is being added. Okay, so now let's read through this. As we read through it, we're going to pick out the pieces of information and fill them in for our variables. Okay, temperature of 15 grams, or grams, I hear grams, I know that's mass. I'm going to put that in for my mass down here. 15 grams is increased by 30 degrees Celsius. We know that Celsius means we're doing temperature. And how much heat? Okay, how much heat? When it's talking about heat, I know that is my Q, so we're going to put X for that. And all right, so I have my temperature, I have my heat, I have my mass. Wait a second. How am I supposed to solve this if I have two things missing? Do I put an X here? No, right? We have C. We have C for water. It's hiding on our handy dandy reference table, right there. C. So this is what we're going to use for C in that problem. Okay, so 4.184 from our reference table. Is that not right there? Yep. And now all we have to do is take our variables and plug them into the equation. So what do I have for Q? X. What do I have for M? 15 grams. What do I have for C? 4.18 joules gram Kelvin. And what do I have for delta T? 30 degrees Celsius. Great. And that is going to give us Q is equal to 189 joules. Great. All right, next up. A 500 gram sample of water. So first we're predicting if it's exothermic or endothermic. And a 500 gram sample of water at 19 degrees Celsius absorbs. That's the big hint here, right? So if it's absorbing heat, that means heat is entering the water. That's going to be endothermic. Okay, temperature is increasing. Heat is being added. Absorbed is our big. Okay, so we're going to read through the question, pick out our variables so we can put them into the equation. All right, 500 grams, so we know that's our mass. Water at 19 degrees, so at, that's what we're starting with. That is our initial temperature. Absorbs 8.40 kilojoules of heat. Okay, kilojoules, let's talk about that real quick. So in order to go from joules to kilojoules, you just have to multiply by 1,000. And the way that I do it is I do 1, 2, 3. So that's going to give me I don't think they give you that on their Regents anymore, but just in case for these kinds of questions, if you see them pop up on Castle Learning, I'm not going to give you one on the test on Monday, so don't worry about it. Just for this one for now. Okay, so 8400 joules. And what will be the final temperature of the water. Okay, so now I know I'm solving for that. Oh my gosh, same problem. I don't have C. Yes, you do. Reference table. Okay, and I just want to point out that it is important for us to switch to joules instead of using kilojoules. So joules, there's joules in your specific heat capacity. So if you do a question where it gives it to you in kilojoules and you keep it as kilojoules, your answer is going to be off by a few decimal places. Okay, so now we'll do the same thing. We'll just plug them in. All right, my Q, I'm actually going to move it up here because this one is, I'm going to do the algebra to show it to you. Okay, it's equal to 500 grams. Specific heat capacity of water. And here is where the very important temperature, final temperature, initial situation comes in. So final is the one that comes first in the equation. T final minus T initial. So my final, right, is my X, and my initial is my 19. Okay. So now to solve for this. So first you have to divide both sides. Okay, and that is going to give, so when I divide both sides by 500 times 4.18, that's going to give me 4.02 is equal to X minus 19. And then from there, you just add 19 to both sides. That will give me X equals, it's going to turn out to be 22.99 something. Let's just say 23. 23 what? 23 degrees Celsius. Okay, moving on. Number 3. And again, we're going to predict endothermic or exothermic. Okay. Temperature of 50 grams of water was raised, right? Raised. So we are increasing the temperature, meaning we need to add heat. It's going to be endothermic, right? Heat is entering. And the reason is because temperature is increasing. Addition of joules. Heat's being added. Great. Okay. So, again, go through, pick out our variables, pop them in the equation. 50 grams mass. 50 degrees Celsius. Raised to, right? So if it's raised to 50 degrees Celsius, that means 50 degrees Celsius is our final temperature. Addition of 4,200 joules. So joules is our heat, our unit for heat. And what was the initial temperature? So that means that is our X. And what is C? Right on the reference table. Okay. So, plug them on in. Q, M, C, delta T. Okay, again, here is where our final initial situation is very important. So you have T final minus T initial. So our final temperature, if we go back to our variables, is going to be 50 minus our initial temperature is what we're looking for. So we're going to put an x there. And again, I'll go through the algebra on this one. Divide both sides. That will give us 209. Move that up a little. Okay, so you could go about this two different ways. I'm just going to subtract 50 from both sides. And the reason we are subtracting here is because 50 has an imaginary positive sign in front of it, right? If it doesn't have a negative sign, that automatically means it's positive. Subtract 50 from both sides, and that will give you negative 29.9, let's just call it 30. Negative 30 equals negative x. So you could divide both sides by -1. That will, or you can multiply it by -1. Either way, you're going to get x equals 30. 30 what? 30 degrees Celsius.